Now we're going to talk about absolute value inequalities because they're a little bit different, and I want to make sure you have the concept down in case you get questions like this on a test or a quiz. So say we have a problem like this. On the left-hand side of the inequality, you have the expression x is minus 8, but you want to take the absolute value of that, and you want to say that that expression is greater than or equal to 5. Now it can help you get an intuitive idea of what's going on here if you fill in values for x. But in order to solve problems on quizzes or exams, there's some simple steps you can memorize and follow through with, and you should always arrive at the correct answer. So here's how to solve absolute value inequalities. You're in a sense solving two different problems. So what you would do is you would write x minus 8 is greater than or equal to 5. And then separately you would write x minus 8 is less than or equal to negative 5. So basically you're reversing the sign of the inequality, and then the side of the inequality that the variable is not on becomes negative. If you solve both of these, you'll come up with two expressions that describe the inequality, and then you can graph that. Because of the nature of the answer, you can't really write this into one expression. So let's take a look at the left-hand side first. Our goal is to isolate x on one side of the inequality by itself. So to do that, we can add 8 to both sides of the equation. On the left-hand side, what we get is negative 8 plus 8 becomes 0, so we're left with just x. On the right-hand side of the equation, we have 5 plus 8, which evaluates to 13. So what we end up with is x is greater than or equal to 13. Now let's do the right side. Again, we have our x minus 8. But since we're dealing with an absolute value inequality, we have x minus 8 is less than or equal to negative 5. Since we're trying to isolate x, we do as we did before, and we add 8 to both sides of the equation. Again, the negative 8 plus 8 becomes 0, which leaves us with x isolated on the left-hand side of the inequality. And since we added 8 to the left side of the inequality, we have to do the same thing to the right. So we do that and get negative 5 plus 8 is equal to positive 3, and that leaves us with the expression that x is less than or equal to 3. If you were asked to plot this on a graph, you could start with either expression, x is greater than or equal to 13. You'll write the bracket, right, because the 13 is inclusive. That means x can equal 13. Then you could draw an arrow going to the positive side of the x-axis. So this expression is half closed, and it's unbounded because you can go to infinity in the positive direction. Now let's evaluate the other expression. We have x is less than or equal to 3. So since 3 can be included in the solution, we use a square bracket again. Then we draw an arrow going to the left on the x-axis. So it covers all the points from positive 3 to 0, but you can keep on going to negative infinity. So this part of the solution is unbounded as well. And that's pretty much it for absolute value inequalities. When we come back, we're going to talk about graphing linear inequalities.